Land subsidence is the gradual settling or sudden sinking of Earth's surface due to subsurface movement of Earth materials. This phenomena can be triggered by various natural and human activities including groundwater extraction, mining, natural gas extraction, and geological processes. Subsidence results in a reduction of the land surface elevation and can lead to significant environmental, structural, and economic consequences. What are the causes of land subsidence? First one is groundwater extraction. The most common cause of land subsidence is the excessive withdrawal of groundwater. When water is extracted from the ground, it reduces the hydrostatic pressure that supports the pore spaces within aquifers. Over time, this causes the sediments to compact and the ground to sink. Second one is mining and natural gas extraction. Mining activities, especially those that involve removing large volumes of minerals, can lead to the collapse of underground spaces, causing the surface to sink. Similarly, the extraction of natural gas or oil can lead to subsidence due to the reduction of pressure within underground reservoirs. Third one is the natural causes. Natural processes such as tectonic activity, soil compaction due to natural drying and wetting cycles, and the dissolution of soluble rocks, also known as karst process, can also contribute to land subsidence. Let's discuss the issue of land subsidence in Rajasthan. In Rajasthan, particularly in the desert districts of Bikaner and Barmer, land subsidence has become a notable environmental issue. The primary cause of subsidence in these regions is the excessive exploitation of groundwater. Rajasthan, being one of the driest states in India, relies heavily on groundwater for agricultural, industrial, and domestic needs. Over the years, this has led to a significant depletion of groundwater levels. Groundwater depletion. The continuous and unsustainable extraction of groundwater has led to the lowering of water table. As water is pumped out faster than it can be replenished, the aquifer rocks, which were previously saturated with water, begin to compact. This compaction reduces the pore spaces and leading to sinking of the land surface. Second one is geological factors. The subsurface strata in Rajasthan, particularly in the desert areas, consists of aeolian deposits and hard rock formations. At the contact zones of these formations, excessive groundwater extraction has caused the pore spaces to dry out and compact, further exacerbating the subsidence issue. Its impact on infrastructure. Land subsidence in these regions has led to various problems including the cracking and sinking of buildings, damage of roads and pipelines, and reduced agricultural productivity due to altered land surfaces and disrupted irrigation systems. Environmental consequences. The alteration of natural land surfaces can disrupt the local ecosystem, affect soil stability, and increase the risk of further environmental degradation. It can also lead to the formation of new low-lying areas that may become prone to flooding during heavy rains. Let's see the solutions and mitigation strategies. Addressing land subsidence in Rajasthan requires a multifaceted approach. First one is sustainable water management. Implementing more sustainable water extraction practices is crucial. This includes promoting the use of surface water resources, rainwater harvesting, and artificial recharge of aquifers to replenish groundwater levels. Second one is regulation and monitoring. Strict regulations on groundwater extraction and continuous monitoring of groundwater levels can help prevent excessive depletion. Using technology to monitor and manage water resources can provide real-time data to inform policy decisions. Third one is public awareness. Educating local communities about the causes and impacts of land subsidence as well as the importance of water conservation can encourage more responsible water use practices. Fourth one is alternative agricultural practices. Promoting less water-intensive crops and efficient irrigation techniques such as drip irrigation can help reduce the demand for groundwater in agricultural sectors. To conclude, land subsidence in Rajasthan is a crucial issue driven by unsustainable groundwater extraction. Addressing this requires coordinated efforts between government authorities, local communities, and stakeholders to implement sustainable water management practices and mitigate the adverse impacts of subsidence.